Hey there. So I got a story for you. About a month ago, I was sitting around the house and I've got a pile of potatoes and I'm thinking, you know what might be fun with these guys? I should make some gnocchi. That sounds cool, right? Seems pretty simple too. It's got like 3-4 ingredients: flour, potato, salt, maybe a little water, maybe a little oil, I don't know. I've had gnocchi like 3 times in my entire life and it's been several years since that's even happened. So I do like the thing that any logical person does. I sit down on my computer, and I am faced by just walls and walls of rants and secrets. You know, some Italian grandma taught me this, whatever. I don't really care. I just want to make gnocchi, and I don't understand why this has to be so complicated. Now, from my background, I have a PhD in food science. Spent 4-something years getting a degree that taught me how to do stuff like this. So I decided to make a video about it. I thought gnocchi was pretty interesting and I want to dive into the physical and chemical characteristics of it. So I got this whiteboard, bought off Amazon, and I kind of wanted to go through what are the chemical properties of gnocchi. Well, it's carb, so we got carbohydrates, one of people's favorite food groups. If you look into a carbohydrate, every single one shares about the same chemical formula. It's got a carbon, 2 hydrogens, and 1 oxygen, and it always stays in that same ratio. Of course, there's a few exceptions, but we're not going to talk about that. Now, if you squint your eyes at this formula, you'll see H2O, water, hydrate, and C, carbon, carbo. So we get carbo with water, hydrate, carbohydrate. Isn't that great? Scientists just naming things for what they are. Now, the important thing on this is going to be glucose. This is the carbohydrate that most plants are going to be making. They do it through photosynthesis, sunlight, CO2, water, glucose. There's a lot more to it, but this is all we really care about for this video. It's going to have C6H12, O6, same ratio, carbohydrate. Now, on this guy, we're going to have 6 different carbons, 1, 2, 3, 4, 5, 6. And for demonstration purposes, I'm going to use this little bead here. I don't know if I can get it in focus, but I'm going to use this guy. This will be our glucose molecule. So what is glucose for in a plant? So it's going to be one of the primary ways to store energy. So it's getting energy from sunlight, but it has to put it somewhere because come wintertime, there's not going to be a lot of sun. The plant is going to need to rely on something else to survive. So glucose is that primary source of energy storage. However, in a plant, it's actually going to be dissolved in water. And water loves glucose. Oh my gosh. There's a reason why it dissolves really well in water. If you just take a teaspoon of sugar, stir it in water, boom, dissolve. It's great, right? Water loves glucose, glucose loves water. The issue with that is that every single glucose molecule that you have is going to be accompanied by a lot of water molecules. So you're going to have several water molecules chipping along with the glucose. And that creates a problem because as the plant keeps shoving glucose molecules into storage cells, into a potato cell, it's going to keep growing and growing and growing until eventually it might actually pop and kill the cell. It's not good. So what we do here is the plant actually takes this first carbon and this 4th carbon in a molecule, and it makes what's called amylose by just stringing glucose molecules together. And honestly, what that looks like is just beads on a string. Doesn't have to be complicated, really simple, just glucose beaded together. That's still not perfect. It's not a great solution. So what the plant ended up doing is it makes this thing called starch, amylopectin, which is a branch version of glucose. So if we go back to that glucose molecule, it's actually going to start attaching glucose branches or amylose branches onto this 6 carbon here to form a molecule called amylopectin. Now compared to amylose, which is whipping across the screen right now, amylopectin is a very large and complex molecule. As it's being synthesized, plants actually wrap amylopectin around itself to form these double helices. A published version of what this looks like is up in the top left. And just like before, we have a lot of water inside the potato cell. But in this case, the water cannot get inside the amylopectin. Those branches wrapped around themselves occlude water
and form these things called amyloplasts, which host starch granules. However, when we start applying heat by cooking the starch, we start unwinding these branches by shaking it vigorously. That is a process called gelatinization. As the starch branches begin to open up, water is now able to rush inside in between them, and that's going to cause the starch to swell. This is going to help the potato actually be digestible, which is why we were cooking it in the first place. Now, a little stop motion video is kind of silly and fun, but what does this actually look like? Well, under high enough power on a microscope, we can actually see the starch granules within a potato cell. However, just like in our demo, once we start cooking the potato cell, those starch branches start unwinding and they begin to swell. Eventually, they're going to swell so much they'll take up the entire space within the potato cell. In this state, the potato will be fluffy. However, if you break up the cell walls, the starch is going to start to leak out and become gummy.
So once the potato's cooked, we got this guy, we bake it, we can boil it, we can do whatever we want with it. And we end up with cell walls stuffed with gelatinized starch. And we want to mechanically break those up, and we're going to do that either with a potato ricer or a microplane, a really fine grater essentially. We're not going to use a fork, we're going to use a masher, because what we're trying to do is preserve as many of the cell walls as possible. Because when we mechanically separate it, we're going to get what are basically islands of potato cells here. And when we add flour, or some people add eggs, some people add ricotta, what we're going to be doing is essentially creating a barrier between these islands. So when we start eating it, we start breaking up those cell walls, we have these protein, starch, fat barriers in between these islands, and that's going to prevent us from making mashed potatoes. That's going to prevent really gummy gnocchi. We're not making a starch gel here. We're keeping all the starch pockets separate from each other. So in order to accomplish this, what we're going to do is we're going to grate or potato rice the gnocchi out into a very thin layer. We don't want to pile it. I see this all the time online. People pile it up, they put the flour in the middle, whatever. That's not going to help you. You want to spread the flour out and the potatoes out as evenly as possible, so every single little grain and granule or whatever is covered in flour. So once we have that, we're going to have that barrier that's going to help our gnocchi from being gummy. And we're just going to gently knead it. You just want to fold it over itself enough such that the flour becomes hydrated. You've formed enough gluten. You just want a little bit because you don't want it overly dense and chewy. And once you see just like a couple fissures, a couple cracks in the dough, it's mostly staying together, that's time to just start cutting it up, throw it in the water, and start cooking it. To be honest, that's kind of it. That's gnocchi in a nutshell. What we're doing is we're cooking potatoes, gelatinizing starch within the cells. That gelatinized starch is separated by cell walls. We gently separate the cells from each other, coat it in a barrier such as flour, egg, ricotta, whatever. Flour is just fine. And then we gently knead it so we maintain that barrier. And once that dough comes together, you throw it in the water, you cook it, and you should end up with some pretty fluffy, toothsome, delicious gnocchi. That's all I got for this. If you have any questions or want to know more, leave a comment. I'll probably reply. To be honest, I thought this was kind of fun. So ask any questions, leave comments, and thanks for watching if you made it this far. That's all I got.